Welcome to this explainer. Did you know a single modern AI rack can consume as much power as an entire small neighborhood? It's wild. Today we're diving straight into the immense pressure that's facing modern data centers and how to actually build a unified AI infrastructure from the ground up. If you're managing complex environments right now, you already know that the sheer scale of compute required for modern AI and deep learning, well, it isn't just pushing the limits of our software, it's literally testing the physical limits of our hardware, our power grids, and our cooling systems.
Okay, let's jump right into this reality of intense AI workloads, massive power demands, and incredibly complex cooling constraints. Because when you're running large-scale GPU-accelerated clusters, the traditional methods, walking the floor, checking disjointed monitoring tools, they simply don't cut it anymore. The stakes are just way too high. So we really have to ask ourselves, is your data center managing you, or are you actually managing it?
Picture the chaos for a second. You've got stressed IT teams facing massive alert storms, getting critical error messages from all over the infrastructure, but with absolutely zero system correlation. Services are actively failing, and your operators are left guessing. Is this a power trip? Is it a coolant leak in a distribution unit or CDU? Or, wait, is it just a standard server fault? Without centralized visibility, teams are basically forced into manual rack-by-rack investigations, and that leads to devastating, extended downtime.
To solve this, we are going to explore the Supermicro SuperCloud Software Suite layer by layer. We'll cover 1. A modular software stack, 2. Visibility and hardware control, 3. Automating operations and deployments, 4. Empowering the AI developer, and 5. Building your AI cloud. Let's get to it.
Starting with Section 1, a modular software stack, independent but integrated.
What's genuinely fascinating here is that these 4 tiers, Composer, Automation Center, Director, and Developer Console, are designed as a huge relief for IT teams because of their flexible consumption. You absolutely do not have to rip and replace everything in your current data center. If you just need bare metal services, you deploy just that. Just need monitoring, you deploy that. You pick exactly what you need without sweating over cross-platform dependencies. But obviously, when you do use them together, you totally avoid the operational and security nightmares of trying to stitch together completely different platforms.
Moving along to Section 2, Visibility and Hardware Control. Basically, taming the physical layer.
The contrast here is literally night and day. Without SuperCloud Composer, or SCC, you essentially have zero data center observability. You're dealing with that flood of uncoordinated alerts and manual guesswork just trying to find a tripped PDU or a failing cooling loop. But the second you introduce SCC, that guesswork is eliminated. We replace it with centralized visibility, clear location awareness right down to the specific node, and, this is the big one, automated, policy-driven responses. Like, if there's a coolant leak, SCC can execute a graceful shutdown automatically to prevent a total meltdown.
This gives you a true single pane of glass. By using standards-based telemetry, like the industry standard Redfish protocol, SCC gives you real-time health, power, and thermal monitoring that is actively correlated across your servers, GPUs, PDUs, and your cooling systems at both the rack and pod level. Plus, it integrates perfectly with your existing systems, automatically firing off webhooks or creating incidents right in ServiceNow, so your operators are never left in the dark.
But hey, seeing the problem is really only half the battle. SuperCloud Director, or SCD, is the next step up. Without it, you're stuck with manual setups, high operational costs, inconsistent builds, and customers waiting days for resources. With Director, you actually transform that rigid physical infrastructure into remotely delivered self-service bare metal capacity. You literally go from days of setup to just minutes. It's a massive shift in operational velocity.
Under the hood, it's utilizing the OpenStack Ironic engine for bare metal provisioning and Neutron for networking. So Director gives you incredibly strong hardware-level isolation. Think about what that means for different business units or highly regulated sovereign environments. You get secure infrastructure partitions and on-demand GPU allocation, which significantly lowers your overhead while ensuring that one tenant's workload never, ever interferes with another's at the physical hardware level.
All right, Section 3, Automating Operations and Deployments. Scaling the solution.
Without the SuperCloud Automation Center, SAAC for short, operations teams are constantly context switching. They're juggling multiple uncoordinated tools, manual handoffs, and they have terrible visibility into script dependencies. SAAC fixes this by acting as the ultimate air traffic controller. It doesn't replace your existing tools. Instead, it acts as the master conductor for things like Ansible, Terraform, Chef, Puppet, and all your custom shell scripts.
And it brilliantly handles multi-step actions in exactly this logical progression. Imagine taking a massive cluster all the way from hardware bring-up, fleet-wide BIOS and BMC firmware baselining, straight into OS provisioning, and right on up to a platform deployment like Kubernetes or Slurm. It even handles secrets injection centrally. Executing these scalable cluster rollouts with that kind of reliability saves teams just countless hours of manual clicking and configuration.
Next up, Section 4, Empowering the AI Developer, Self-Service Success.
Now we get to arguably the most impactful layer for your end users. Without the SuperCloud Developer Console, or SDX, you're looking at a massive, highly expensive bottleneck. Incredibly valuable GPU nodes sit underutilized because they're oversized for a single task, while other developers are literally waiting days in the ticketing queue just for ops to provision their environments. SDX changes the game entirely. It provides instant self-service access to AI resources, including fractional GPU allocation, so you can squeeze every single ounce of value out of every accelerator you own.
This layer is just so powerful. Developers can essentially build private GPU clouds or deliver GPU as a service directly to their teams. And what's really vital here is the flexibility. SDX offers multi-vendor accelerator support. So whether your workloads need NVIDIA, Intel, or AMD accelerators, you can mix and match them efficiently. You can scale down to a fraction of a GPU or all the way up to cross-node multi-GPU workloads, all through a beautifully standardized Kubernetes native platform.
Finally, Section 5, Building your AI Cloud, from chaos to clarity.
So we started off looking at absolute chaos, right? Guessing what went wrong while alerts flooded the screens. But by stacking Composer for unmatched visibility, Director for isolated bare metal delivery, Automation Center for fleet-wide orchestration, and the Developer Console for rapid self-service access, you completely eliminate that fragmented hardware bottleneck. You transform a rigid physical data center into a flexible, dynamic environment that vastly accelerates your entire AI pipeline.
The tools to achieve complete data center clarity, maximize your GPU investments, and deliver scalable AI environments are literally right in front of us. When you look at the massive demands of tomorrow's AI models colliding with the physical limits of today's facilities, I'll leave you with one final thought. Are you going to let your infrastructure dictate your limits, or are you ready to turn your hardware into a true AI cloud?